The good thing about doing chapter P before we hit chapter 1 is we've done a lot of this already and kind of refreshed on that, but now we're going to pull everything together. Really, pre-cal builds on Algebra 2. So we take a lot of the things we did in Algebra 2 and we just amp them up a little bit, okay? At least for a while. What? Why?
You were great teacher.
Well, thank you, but I'm sorry you didn't like it. All right. We're going to talk. Ooh, look at that lag.
I was like, what is it doing? Huh?
I have the whole word on my screen. There we go. Does it always do that?
No.
Versus graphically. So that's where you'll need your calculators. So thank you, Akeem, for going to get the calculators. We appreciate it. So when we solve an equation algebraically, there are lots of different methods we can use. And I think the hard part is determining the method that we need to use when we solve things. So let me show you an example. If I have this equation, and I'm asked to solve it algebraically, I'm looking at it going, oh my goodness, I don't know, right? Does anybody have an idea where you'd start with that? Move 6x to the third to the other side. If you move that to the other side, and I'm going to say you're not wrong, okay? In general, though, what I have found to make your life easier is whatever your biggest exponent is, try to keep that term positive. Does that make sense? So maybe instead of moving the 6x to the third, move the other two. But your thought process is right because we need to get everything together on the same side, right? Mm-hmm. All right, so if I move these two to this side, I have to subtract them. So I have 6x to the third minus 11x squared minus 10x equals 0. Okay? So I'm really looking at this technique of try to make one side 0. Now, why do we make one side equal 0 when we're solving? Okay, well, quadratic formula is one answer, but this is a cubic, so it's a notch above a quadratic. But still, what's the point? Even if we have a quadratic equal to 0, why do we do that? Somebody knows. Tell you. If we get it factored down into terms or pieces that are being multiplied together to equal 0, then I can set each piece to 0 and solve from there. So that's why I want it to equal 0 to start with. So my next question is, can you factor this in any way? How can I factor it? Okay, so you're right. If it's a quadratic, I can do that. But I got to do something first. What's your first step before you factor always? Check for what? Close. As if you're completing the square. GCF, somebody said it. Greatest common factor. Sorry. I couldn't find you. So I need to take a GCF out if I have one. Does this have a GCF? GCF means I can divide everything by a number, or there's a shared variable that I can take out. X. This one's got 3 x's, 2 x's, and 1 x. So what I can do is I can just pull one of those x's out and write it on the outside. It leaves 2 x's on the 6, it leaves 1 x on the 11, and it just leaves a 10 here. It still equals 0. I'm just writing it another way. Now, Alex, you're absolutely right in what you're fixing to do. And I was pretty impressed with y'all's factoring skills on the test. Most people got the factoring questions right. Why are y'all laughing? Most people did. All right. What? How do I factor this? 6 times negative 10, which is negative 60. Give me two things that multiply to negative 60 but add to what? 11. Negative 11. What are they? What is it? Negative 6 and what? Oh, yes. I'm sorry. I couldn't hear you. The air conditioner's running. Negative 15 and 4, right? Negative 15 plus 4 is negative 11, and when you multiply them, you get negative 60. So what I'm going to do is I'm just going to rewrite that middle term as negative 15x plus 4x minus 2. Thank you. Thank you. Appreciate that. So now I want to look at it as two separate problems, right? What can you take out of the first two terms? 3x. Thank you, Akeem. What's left? I didn't know you finished. I'm going too fast? Okay, I'll stop a second. All right, so the 15 and the 4 came from here. So you multiply 6 and negative 10 together to get 60, right? And so you're looking for two things that multiply to negative 60 but add to negative 11. What can you take out of the second two? 2. What is left? So factored, I have x, 2x minus 5, and what's left? Yes. Now remember, my whole goal was to find out what x equals. And so I know if I'm multiplying things together and they give me 0, then I need to set everything that's being multiplied equal to 0. So I'm going to set even this little x in front. That's x times that. So I'm going to say, okay, x could be 0. Or 2x minus 5 could be 0. Or 3x plus 2 could be 0. Now can you solve each one of those for x? Yes. What do you get? Thinking back to Algebra 2, what in that original equation would have clued you that there were going to be 3 answers? The cube. The biggest exponent should tell us how many solutions we're going to get. Now, if we think about this graphically, what this means this particular graph is crossing the x-axis 3 different places. It's crossing at, come on. It's crossing at 0. It's crossing at 5 over 2. And it's crossing at negative 2/3. Okay? And so to understand, really understand solving polynomials like this, you have to understand that that's doing the same thing. Okay? When you set an equation equal to 0 and you solve, you're finding the places that it crosses the x-axis. Do y'all remember focusing on that in Algebra 2? It was a big, big, big connecting idea in Algebra 2. Was when we set the equation equal to 0 and we solve it, we're finding places where it crosses the x-axis, also known as the zeros of the function. Okay? All right, so we've got multiple ways that we can solve. This is algebraically. I want to take one with you and solve it through graphically and algebraically before we get into some that we'll only solve graphically. So I want you to look at this one. Let's say I have x squared equals 10 minus 4x. And I just said solve. What can I do? Move the 10 and the 4x, right? Keep it in standard form and it'll really make your life easier. So I've got x squared plus 4x minus 10. Now what? Okay. What multiplies to negative 10 and adds to 4? Nothing. It doesn't factor. Which leaves me where? What does that leave me to do? I could complete the square. What else could I do? Quadratic formula. Right? Either of those will always work. If you cannot, see why we did that little review unit before on completing the square and factoring and all that. So either of those will work if you can't factor it. Okay? I'm going to use quadratic formula. And if you don't remember it, opposite b plus minus square root of b squared minus 4ac all over 2a. So x equals opposite b plus minus. Most of you did fairly well with this on the test, but you messed up simplifying it. B squared minus 4 times a times c all over 2a. And this is just, I'm kind of rushing through this because it's just basic. Blech. Now, most of you could get to this point. This is the point where a lot of you kind of fell flat as you tried to simplify. What I want you to do on this, though, because I'm going to show you how we're going to compare methods here. Give me the decimal equivalent here, and you should get two different answers. You'll have to do negative 4 plus the square root of 56 over 2, and then negative 4 minus the square root of 56 over 2. But somebody put that on your calculator and tell me what the decimal equivalents are here. Okay, that's good enough. How about the second one? .7 what? Thank you. Okay, I'm going to show you two different ways that we can also graphically solve this. Okay, this is a very basic example, a very easy example, but we can use this method for some really, really nasty equations that we need to solve that can't be factored. I can't get it broke down into factors, and I don't want to use, it might be bigger than a quadratic and I can't use quadratic formula, but I can always solve graphically. So there's two ways to solve graphically, and we're going to use this same problem, but you need your calculator. Method 1 is by finding zeros. And so to do this, your equation must equal 0 before you start. I know this is a lot. I'm almost done. So, we had already manipulated that equation to equal 0, right? Right, we did. We had x squared plus 4x minus 10 equals 0. So what I'm going to do is I'm going to take out my calculator and I'm going to graph that in y equals. You go back to Zoom 6, so we're on a standard window. Hit Zoom 6. Invalid dimension. Your Windows settings were wrong. Your equation that you had equal to 0, x squared plus 4x minus 10. Yeah, I'll put it back in. Oh yeah, it does. It lags. Oh, excuse me. All right. Now remember, where it crosses the x-axis should be the answer. So if I find these two places where it's crossing the x-axis, I should get 1.74 and negative 5.74, right? Mm-hmm. All right. Do y'all remember how to calculate it? Hit second trace and choose 0. Now here's where it gets a little bit confusing as you find it. If you start going left and right, you'll see I call it my little spider. He kind of blinks around as you travel around the curve. You see my spider that's popped back up here? Okay. Put your spider close to the place where it's crossing the x-axis. Don't hit anything else. Just move him around until he's pretty close to that point you're trying to find. Okay. All right. Once you're there, notice it says left bound. Go left 3 times. Click left 3 times. 1, 2. Ooh. Yes. 1, 2, 3, and hit enter. Yeah. Go back to that point and then hit right 3 times. 1, 2, 3, and hit enter. If you do shift F2 for zoom, if you go over, original should be your standard. Well, no. Oh, that might be, yes. When you calculate the zeros, it'll go over there to it. Hit, yours is going to be under, Shift F5 to G solve, and then do 3. And it just automatically gets it to it. If you go over it, it'll do the other one.
So we'll go Shift F5.
Mm-hmm. All right. It's saying now, do you want me to guess? Now understand what I did. I put my spider on the point of intersection. I clicked left 3 times, enter. Back to the point of intersection, right 3 times, enter. And then do you want me to guess? And I hit enter. Yes, I want you to guess. Negative 5.74, which is what I got when I did it algebraically. But this time it's on the graph. I'm just finding where, okay? What did it ask you? Did you hit enter after you went 3 clicks to the left? Now what's it say? Okay, go back to the point and go right. Go back to the point where it's crossing. And then hit right 3 more times. No, see, I watched you. I said hit right 3 more times.
And now press enter. I just pressed enter.
Yeah, you did. Let me just pause this. Y'all do the second point. Calculate the second point and make sure you get 1.74. Do it. Do it now. What's backwards? But you got the right zeros?
I all got the right thing.
I got it.
Like if you have a short side, it's gonna go right.
Uh-huh.
Short side on the left.
Uh-oh. No, we got 1.74, Chrissy.
You find the other point by going to the other side.
Do the same thing. All right, I promised you 2 graphical methods. I don't like standing up here this long in front of you, so I promise I'm almost done. I won't do a really hard one with you because really if you can put them in your calculator, there's not any one any harder than the other. The other method, which is method 2. Did you do second trace? We're going to do the same equation, but this time we're going to do it a little bit different, okay? This is probably a method you have not used before, but it's a really good method to use because it's a little bit easier. We're going to graph each side of the equal sign. That's supposed to say sign. In here? Did we do this in here? Did we solve by intersection in here?
Yeah.
I feel like we might have now that you say that, though.
Well, we can do it again.
Okay, it's all right.
Oh, wait, we did talk about intersections. You told us how to go through intersections.
All right, so if we've already done it, then this is just a recap for you. I can take that equation before I made it equal 0. Okay, so what I started with initially. So remember it was x squared equals 10 minus 4x. And what I can do is I can graph 2 different things. I can graph x squared and 10 minus 4x. And then I find where they cross. And hopefully they're going to cross at 2 different points. They're going to cross at 1.74 and negative 5.74. Yep, same equation. Yep. We're just doing a different way. So this will be 3 different ways of finding the same answer. Right, we're going to start that original equation. So one side was x squared, and the other side was 10 minus 4x, right? When I graph that, how'd I do what? That line is 10 minus 4x. Sometimes it is a lot easier to do it that way. Okay. Here's the problem, though. Whenever I'm doing both of them this way, look at my graph. I'm going to have to adjust so I can see. Did it just go out again? Okay. So I got to go back in that window. Yeah. X squared and 10 minus 4x. Okay. So if you hit the button that says window, I need to see further up. That's my y-axis. So I'm going to take that y maximum up to who's done it? What'd you take it up to? 40. And now if I graph it, see what I'm trying to do is I'm trying to get to where I can see both intersection points. I'm sorry. Okay. Okay.
I just said got the X.
Okay. Let me go all the way back. In y equals. This is one side of the equation and the second side of the equation, right? Okay. Is everybody with me on that part?
Yes.
When I graph it initially, I usually assume 6, right? That's a 10 by 10 window. And I notice as I graph this is a line I can see where it's intersecting right here.
I got it.
But I know it's going to intersect somewhere else way up here, and I need to see that.
Okay.
Okay? So what I'm going to do to see that is I'm going to hit the button that says window. And I'm going to go down to my y maximum, because the y is what lets me see up and down. Okay? I'm going to take that y maximum up to like 40 or 50 so that I can see higher up. So if you just change it to 40 and then you hit graph, The goal, remember, is to be able to see both intersection points. And now I can see them. So I did all that work, which isn't as much as what it seems because we didn't, algebraically we haven't done anything. We put it in exactly the way it was given to us in Y1 and Y2. Now go second trace. What do you think I'm going to choose this time? Intersect. This one is easier, okay? There's no left bound, right bound guess. It says first curve. It's just saying give me one of the graphs. So hit enter. Notice how it jumped now to the line. Is that the second graph you want to find the intersection of? Yes. Hit enter again. Now do you want me to guess? Enter one more time. You basically go right next to the point and hit enter, enter, enter. What do you notice about that X value? 1.74. It's the same thing. Guess what I'm going to find if I go to the other intersection point? Second trace. When you do the intersection this time, to make sure you get to the right intersection, just go kind of close to that. That's pretty close. Enter, enter, enter. What way do you like better? Algebraic, graph by zeros, or graph by intersection?
I don't know.
Intersection?
I guess it's going to depend on the...
It'll depend on the problem too. It really will. What's up? Remember, if you see, this is when you're doing algebraically. If you only see one X, do SAD map. Okay, like number 30 in your homework looks like this. X, come on, plus 11 squared equals 121. Don't FOIL that out. What could you do first? Square root. Take the square root and then subtract 11. Okay? Don't start trying to do more than what you have to do. But it's because I only see X in this whole equation one time right here. That tells me I can just backwards PEMDAS and solve.